Hey there, I'm Gabe Hollenby, a Senior Developer Advocate here at Amazon Web Services. And in this session, I'm going to cover 9 great tips to help you keep your AWS costs down. Whether you're seeing usage increase because your customers are relying more than ever on your services, or perhaps you just want to dial in your spending for the road ahead. In either case, there are things you can and should do to optimize your cloud costs. And in this session, I've highlighted 9 quick cost optimizations that every customer should probably consider. Give me about 30 minutes of your time, and I'll give you the tools and approaches that can have a significant impact on your cloud costs right now and into the future as well. Of course, in the context of optimization, in an ideal world, we'd sit down together and have a detailed conversation about your specific workloads. And then we would come up with a solution-specific plan to re-architect your system for cost. Of course, that takes a lot of time, and each of your systems will vary on a case-by-case basis. However, no matter what your specific situation involves, it's likely there are at least a few pragmatic steps you can take to reduce your spend in the cloud. All of these tips won't apply to everyone, but everyone will probably find some value in at least some of them. So these are the 9 ways to reduce your AWS bill that we're going to cover. Ready? Let's dive in. Number 1, stop paying for idle EC2 and RDS instances. If you have workloads running in non-production environments, such as development, QA, testing, or non-mission critical workloads, and if it's not part of your operational process to shut these resources down during evenings, weekends, and holidays, then you might be paying for lots of idle time in Amazon EC2 instances and RDS databases. In many cases, teams keep these types of environments running through nights and weekends because it's just too much work to automate the stopping and starting of these environments to follow a schedule. Well, happily for you, AWS now has made it much easier to operationalize instance scheduling in your account by providing a pre-built CloudFormation-based solution called the AWS Instance Scheduler. The AWS Instance Scheduler is a simple AWS-provided solution that enables you to easily configure custom start and stop schedules for your EC2 and RDS instances. The solution is easy to deploy and can help reduce your operational costs. Instance scheduling allows you to leverage the elastic nature of the cloud and pay only for what you need. You can stop and restart EC2 and RDS instances. When these instances are stopped, you no longer incur hourly charges. In this graph, for example, you can see how elasticity is being leveraged over the weekend to reduce EC2 costs. Non-critical instances are shut down on Friday night and restarted Monday morning. So if you're running any non-production workloads or environments that consist of EC2 and RDS instances, and these environments can tolerate being turned off while not being used, our recommendation is to automate instance scheduling using the AWS Instance Scheduler to reduce your on-demand EC2 and RDS costs. It takes just minutes to hours to implement, depending on your particular environment size and complexity. Customers who use the solution to shut instances down from Friday 6 p.m. to Monday 6 a.m. can save up to 35% compared to running these instances all weekend. These savings can be realized in minutes, and there's no commitment required. Here's how you get started. First, just install the AWS Instance Scheduler by downloading the CloudFormation template or by launching the solution into your AWS console via the link at the bottom of this slide. Then, create a schedule based on your business requirements and apply a special tag, which the solution uses to discover which resources to manage, to your non-production EC2 and RDS instances to be scheduled. That's it. It's very easy to get started with this tool. Okay, number 2. Use AWS's ARM-based EC2 instances where possible. If you're running popular open source application stacks on EC2 instances, you may be able to easily switch to AWS's new Graviton 2-based instances for substantial savings. AWS Graviton processors are custom built by AWS using 64-bit ARM Neoverse cores to deliver the best price performance for your cloud workloads running in Amazon EC2. Amazon EC2 provides the broadest and deepest portfolio of compute instances, including many that are powered by latest generation Intel and AMD processors. AWS Graviton processors add even more choice to help customers optimize performance and cost for their workloads. The first generation AWS Graviton processors powered Amazon EC2 A1 instances, which were the first ever ARM-based instances on AWS. These instances deliver significant cost savings over other general-purpose instances for scale-out applications, such as web servers, containerized microservices, data and log processing, and other workloads that can run on smaller cores and fit within the available memory footprint. AWS Graviton 2 processors deliver another major leap in performance and capabilities over our first-generation AWS Graviton processors. They power the Amazon EC2, M6G, C6G, and R6G instances, and now the D variants of those same ones, that provide up to 40% better price performance over comparable current generation x86-based instances for a wide variety of workloads, including application servers, microservices, high-performance computing, electronic design automation, gaming, open source databases, and in-memory caches. The AWS Graviton 2 processors also provide enhanced performance for video encoding workloads, hardware acceleration for compression workloads, and support for CPU-based machine learning inference. They deliver 7 times more performance, 4 times more compute cores, 5 times faster memory, and caches that are twice as large. Switching your EC2 instances over to an ARM-based instance type can be a relatively simple process for some cases. It may be as simple as choosing an ARM-based AMI for a new instance and reinstalling your application software. The cost savings of these Graviton 2 instances can deliver up to 40% better price performance over comparable x86 instances for many types of workloads. There's no commitment required, and you can realize these savings quickly as well. Major Linux distributions are available on ARM architecture. Just select the Amazon Machine Image, or AMI, corresponding to the ARM version of your favorite distribution when launching an instance in the AWS Management Console. Be sure to select the 64-bit ARM button on the right part of the screen. You'll find ARM versions of commonly used software packages available for installation through the same mechanisms you currently use, like yum, apt-get, pip, or npm. While some applications may require recompilation, the vast majority of applications that are based on interpreted languages, such as Java, Node.js, Python, and Go, should run unmodified on M6G and the D variant instances. In the rare cases where you need to recompile or debug code, we've assembled some resources to help you get started too. See the page at the bottom of this slide for more info on the tooling we have available to help you build on Graviton 2 instances. Number 3, choose Amazon EC2 Spot for stateless, fault-tolerant, and loosely coupled workloads. Amazon EC2 Spot instances let you take advantage of unused EC2 capacity in the AWS cloud. And when you do, Spot instances can give you a discount up to 90% compared to the on-demand prices. You can use Spot instances for various stateless, fault-tolerant, or flexible applications, such as big data, containerized workloads, CI/CD, web servers, high-performance computing, and test and dev workloads. And because Spot instances are tightly integrated with AWS services such as autoscaling, Elastic MapReduce, Elastic Container Services, CloudFormation, Data Pipeline, and AWS Batch, you can choose how to launch and maintain your applications running on Spot instances. The way Spot instances work is that you opt in to starting a Spot instance when you launch a new EC2 instance. And during this opt-in, you specify a maximum hourly price that you're willing to pay for the instance. And as long as AWS has spare capacity for the instance type you've selected, your instance will continue to run, often at a very large discount over the on-demand price. Then if demand for your Spot instance type increases beyond the maximum price you've specified, your instance will receive a 2-minute termination notice so that it can clean up any work in progress and prepare to be reclaimed by AWS. Our recommendation is to choose Spot instances for workloads that are stateless, fault-tolerant, and loosely coupled. Also, you should think about Spot first as an approach when developing new workloads. Your implementation can take hours or days for workloads that are already in the ideal state where your code can tolerate being terminated and resumed at a later time. Or it may take weeks for you to port your application into a Spot-friendly design, depending on your environment complexity. Now, Spot instances are available at an up to 90% discount compared to on-demand prices, and the time to realize these savings depends on when it's implemented for you. If you implement Spot now, you can start realizing the savings now, and no commitment is required. If you're already running Spot-friendly workloads, such as big data, containers, CI/CD, web servers, high-performance computing, and other test and dev workloads, we have a number of specific resources online to help you get started. I recommend starting with the EC2 Spot workshops. This is the first link on this slide, and watching the Tech Talk on CI/CD workloads with Spot, the second link here. Okay, number 4, stop paying for underutilized EC2 instances. If you're running EC2 workloads that are compute, but not memory intensive, and the EC2 instances utilize less than 40% of their CPU, you're paying for over-provisioned instances. In this case, you should use the AWS Cost Explorer tool's resource optimization recommendation to identify overpriced EC2 instances and review the suggested instance right-sizing and termination recommendations shown there. Our recommendation is to review the resource optimization recommendations generated by AWS Cost Explorer to determine which EC2 instances you can right-size or terminate. While it takes minutes to hours to review the recommendations, it might take days to perform the resource operations depending on whether the EC2 instances are running in production or non-production environments. Now, the savings potential can vary from hundreds to thousands of dollars depending on the number and types of instances you have provisioned, and they can be realized as soon as the EC2 instances are right-sized or terminated. There's no commitment required. The resource recommendations that are generated are made against a 14-day historic usage, and do note that not all EC2 families are included in the recommendations today. Here's how to get started. First, enable right-sizing recommendations using AWS Cost Explorer's settings option. It might take up to 24 hours to receive your first set of recommendations. Then, view the recommendations and determine whether the recommended EC2 instances belong to compute-intensive workloads. Finally, once you've determined the set of EC2 instances that need to be modified, just terminate or right-size them accordingly. Number 5, use an S3 lifecycle configuration on your bucket to transition objects to appropriate storage classes. If you keep all of your data in Amazon S3 using the default S3 standard storage class, you're likely paying more than you need for storing the data that you don't access frequently. Our recommendation? Use S3 lifecycle configuration rules to automatically transition infrequently accessed data to a lower cost storage class. Each storage class on Amazon S3 is designed for specific availability requirements and access patterns. By transitioning your infrequently accessed data to a lower cost and lower access frequency storage class, such as the infrequent access class, you can save a substantial amount on your storage costs. If you're familiar with the contents of your S3 buckets and you know which data you don't frequently access, you can implement an S3 lifecycle policy rule to transition those objects to a more appropriate storage class in just minutes. Taking one specific case, if you compare the storage costs for the S3 standard class with the S3 infrequent access storage class, you'll see a savings close to 50%. Each of Amazon S3's storage classes, besides the standard class, have a minimum storage duration associated with them. In the case of the infrequent access class, this period is 30 days. To get started, open the Amazon S3 Management Console, navigate to an S3 Buckets Management Settings section, and click on Add Lifecycle Rule. Then you can specify a common key prefix or tag to select the objects that your lifecycle rule will target inside the bucket. You then select the desired storage class to transition matching objects to, and specify the number of days to wait before transitioning objects to the new storage class. Then just review and save your configuration. You can learn more about this feature in the S3 Developer Guide in the Object Lifecycle Management section. Number 6, enable S3 intelligent tiering. So this tip is similar to the previous one with one important distinction. If you're using the S3 standard storage class for cloud-native storage and you don't have time to analyze your S3 usage to properly implement your own lifecycle policies, you might be paying unnecessarily for S3 storage that you're not using. S3 Intelligent Tiering is a storage class that automatically optimizes storage costs by moving data between two access tiers. For a small monthly monitoring and automation fee per object, S3 Intelligent Tiering monitors access patterns and moves objects that have not been accessed for 30 consecutive days to the infrequent access tier. This is a great option for storing data with changing or unknown access patterns. Our recommendation is to enable S3 Intelligent Tiering as you continue to grow your S3 usage, and this just takes minutes to implement. You'll save the most if you write directly to the S3 Intelligent Tiering storage class instead of writing to S3 Standard and moving via an S3 lifecycle policy. This is to save the lifecycle cost. We've seen many customers that follow the above guidance save 20 to 30%, and you can theoretically save up to 40%. The larger the average object size, the more savings you'll observe. Once you enable it, it takes 30 days to realize the savings after they are placed in the frequent access tier and transition to the infrequent access tier. There's no commitment required to use S3 Intelligent Tiering. There are multiple ways to get started, but here are some examples of how to do it. For new objects with unknown access patterns, you can load them directly into S3 Intelligent Tier and let AWS automatically optimize your S3 costs. For existing objects, you can create a lifecycle rule that transitions the objects to use intelligent tiering. For more information, visit the link at the bottom of this slide. Number 7, use an S3 gateway endpoint if you can. A great optimization you may be able to make if you're working with S3 from resources in a private VPC subnet in the same region as your S3 bucket is to use an S3 VPC gateway endpoint. Many AWS services support something called a VPC endpoint, which enables you to privately connect your VPC to supported AWS services and VPC endpoint services without requiring an internet gateway, a NAT device or gateway, or a VPN connection. Instances in your VPC do not require a public IP address to communicate with resources through a service's VPC endpoint. And when using a VPC endpoint, the traffic between your VPC and the other service does not leave the Amazon network. Some VPC endpoints carry an additional cost to use, but getting set up and using an S3 gateway endpoint is free of charge. And it can be a great way to optimize your costs for cases where you have resources in a private subnet trying to communicate with an S3 bucket in the same region. Using an S3 gateway endpoint is a relatively quick addition you can make to your VPCs, assuming that you have instances writing to buckets in the same region. If you go this route, you could potentially terminate any NAT gateways you were using, assuming that the instances in your private subnets have no other need for internet access, saving on both the monthly NAT gateway costs as well as on the transfer charges for data flowing through the NAT gateway as well. NAT gateways are charged on a per NAT gateway hour basis, so if you terminate your NAT gateway, you can quickly realize savings, and there are no commitments required to using an S3 gateway endpoint. For example, if you configure a VPC gateway endpoint for S3, then your EC2 instances in the same region as your S3 bucket can communicate directly with Amazon S3 instead of routing that traffic through a NAT gateway. This results in less load on your NAT gateway, and it will definitely save you outgoing data transfer costs as well. To learn how to configure and use a VPC gateway endpoint for S3, look for the VPC endpoint section in the Amazon VPC user guide documentation linked at the bottom of this slide. Okay, number 8, use the on-demand capacity mode for DynamoDB. Amazon DynamoDB is a key value database that delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, multi-master, durable database with built-in security, backup and restore, and in-memory caching for internet-scale applications. DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. DynamoDB allows you to provision a fixed capacity for your tables, but it also has an on-demand capacity mode that's much more flexible. If you are using provisioned capacity for DynamoDB tables and your application traffic is difficult to predict and control, or if your workload has large spikes of short duration, or your average table utilization is well below the peak, then you might be paying unnecessarily for provisioned capacity that you're not using. Amazon DynamoDB on-demand capacity mode is a flexible billing option for DynamoDB capable of serving thousands of requests per second without requiring capacity planning. With on-demand capacity mode, you pay per request for the data reads and writes your application performs on your tables. You do not need to specify how much read and write throughput you expect your application to perform, as DynamoDB automatically accommodates your workloads as they ramp up or down. Our recommendation is to configure your Dynamo tables with on-demand capacity for tables as you continue to grow your DynamoDB usage, and this takes minutes to implement. Your savings potential will depend on the number of reads and writes your application performs on your table. To quantify your potential savings for tables that are idle or for hard-to-predict workloads, we recommend switching to an on-demand capacity mode for a short period of time and comparing your costs to when your tables were configured with provisioned capacity. You will start realizing savings as soon as your table is configured with on-demand capacity, and you can toggle between provisioned or on-demand capacity modes once every 24 hours. To get started, you can configure on-demand capacity mode for existing DynamoDB tables or for new tables. For more information, just visit the link at the bottom of this slide. And lastly, number 9, use AWS Compute Savings Plans. If your workloads are indexed on compute resources that are always on, or your compute usage is consistent and you're currently paying the default on-demand pricing, Compute Savings Plans can help reduce the cost of those compute resources. AWS Compute Savings Plans allow you to commit to a consistent amount of usage in the form of an hourly spend in exchange for a lower price for that usage. Compute Savings Plans provide the most flexibility and help reduce usage costs. These plans automatically apply to EC2 instance usage regardless of instance family, size, availability zone, region, operating system, tenancy, and between compute options. Compute Savings Plans also allow you to move a workload from EC2 to Fargate and, most recently, to AWS Lambda as well at any time, and you automatically continue to receive discounts. So, if you have compute usage that is consistent, our recommendation is to choose a 1-year, no upfront compute savings plan. It takes just hours to implement. Compared to on-demand prices, a 1-year, no upfront compute savings plan will provide up to 54% discount, and the savings can be realized within hours of purchase. This requires a 1-year commitment, but the break-even point is typically from 7 to 9 months. Here's how you get started. In your AWS Cost Explorer console, review your savings plan recommendations, then customize those recommendations based on your needs, such as term length and payment option. And lastly, add your preferred savings plan's amount to the cart and purchase. So there you have it, 9 ways to help you control your costs in the AWS cloud. And although you've seen many ways to reduce your costs today, there are a number of self-service options for you to use in your cost optimization journey. To understand your costs, use AWS Cost Explorer. To control your costs, use the AWS Budgets tooling. And to optimize your costs, use AWS Recommendations. Our AWS Digital Training offers free on-demand digital courses that help you learn new cloud skills and services when and where is convenient for you. Register for free AWS Digital Training at aws.training. Well, we hope you found this session interesting. Please let me give you a kind reminder to complete the survey. Let us know what you thought of today's event and how we can improve the event experience for you in the future. And finally, I just want to say thank you for taking the time to let me share this session with you today. I know your time is really valuable, and it means a lot to me that you stayed with me here until the end. If you have any questions or comments that you'd like to share about today's session, please just get in touch. You can find me on LinkedIn and Twitter at Gabe Hollenby. Thanks again.